A histogram is nothing more than a special kind of bar graph, but it's a bar graph in which the bars are shoulder to shoulder with one another. Here's an example of a histogram. Now, we're going to look at the information that gives rise to this graph, because it turns out that the information illustrated in each of the bars is information that falls within an interval. And within the interval, for example, from 18 to 20, we have this many items, the number associated with this level, which is, it looks like it to be about 12. You see, so there were 12 items that fell into this interval of numbers. Now this is called a class interval. There are different, we can think of them as classes or classifications, you see, for the numbers. But information just kind of fell into various intervals of numbers. I do want you to notice that the intervals here are of the same length. That is, 18 to 20 is a length of 2, and 20 to 22, 22 to 24, these are always going to be equal intervals when this kind of graph is set up, when the histogram is set up. Well, we're talking about fuel usage here. I didn't mention that before. This is miles per gallon along the bottom and some number of cars that fall within each of these intervals. Let's come back over here and talk about how the graph was actually structured. I think this will give us a better feeling for the histogram. So this is a histogram. We're talking about fuel usage here. 92 cars were in this particular test or this survey. And class intervals were created. It turns out that when a survey like this comes about and you have the 92 automobiles were tested, and the numbers came in between, about 18, above 18, but less than 30. You see, miles per gallon for the fuel usage. And then all of these intervals were created as a result of that, and then the number of cars falling within each interval were identified. So within, from 18 to 20, 12 automobiles fell into that category or into that class interval. And in the interval 20 to 22, 19 automobiles fell into that category. Well, as I say, these are called class intervals, and these are called class frequencies, the number of cars that fall within the interval, class frequencies. Okay, and then you take these numbers, you see, and associate them with the interval, and you get the bars on the bar graph or on the histogram. All right, so looking at the histogram then, we can answer a number of questions. The questions, though, often have to do with intervals, and that's kind of an important idea. It's not like the problems that we had before with bar graphs, where we had a single item, like a month, for example, and then a number associated with a month. Well, no, here we have an interval of numbers, and then a group of automobiles fall within that particular interval. Let's answer a question. What percent of the cars in the survey had a fuel usage of 26 to 28 miles per gallon? Notice the interval idea here. We're looking for percent, and we're going to apply our basic percent equation, and we might start with our percent statement. That is, what percent of some base is the amount? And notice that it's percent times base, and base is the basis amount, the amount we start with, all of what we have, and all of those ideas are related. So it's what percent of all of the items in the survey are the items that are within this interval. So that's the idea here. What percent in percent? The number of items surveyed, the number of cars here in this test, 92. The number that are in this category, well, that's where we have to look at the graph. So let's come back over here and verify that it's 15. You see, we're looking for the interval of 26 to 28 miles per gallon. That's this interval. We look at the very top of it, and we slide over to the left, and we see the number 15. So there were 15 automobiles within this category or within this interval. So we go back over here and pop in the 15, and now we want to solve the equation, and we do that by dividing on both sides by the 92. Notice that I've expressed n times 92 as 92n. We divide on both sides by 92 to get this cancellation, and on the right, 15 divided by 92 gives us a very long decimal. Let's just round this to the nearest whole percent. We slide the decimal 2 places over, drop the 3, we have 16% approximately. Now, there's another kind of graph that is related to the histogram. It comes right from the histogram, and it's called a frequency polygon. Let me show you how the frequency polygon comes about. Suppose we slide over here and look at the histogram, and suppose we identify the midpoints of each of these intervals. That is, the midpoint of each of the class intervals. So in this class interval from 18 to 20, the midpoint would be 19, so that would be right here. Now let's go to the very top, at 19 here, let's go to the very top of the bar, you see, and make a dot. And then the midpoint of this interval between 20 and 22 would be 21. Let's go to the very top. You see, and so we're just making a dot at the very top of the middle of each of the intervals. And then if we connect those dots, you see, we have what looks like a broken line graph, but it's really a frequency polygon. And then if we could even take off the bars, you see, and then it would really look like a broken line graph, wouldn't it? Well, that's the way that most frequency polygons appear. They appear as broken line graphs, but they emerge from the same kind of structure of information that we have over here. Let's look at another example. Now this is a frequency polygon, and we can't see the bars, you see, for the histogram from which this comes. We could imagine them. We could kind of just look at the nature of the problem and decide what those bars would be like. Let's do that a little bit here. This graph has to do with per capita income, and it's in thousands of dollars. And per capita means per person income. And this was a survey done on all the states in the United States. And we have the number of states that fall into various intervals of per capita income. You see, that's the idea. So between 18 and $22,000, and remember this is in thousands of dollars. So within the interval 18 to $22,000, let's see, this number looks like 13. 13 states fell into that interval. You see, and this is just the top of a bar. I mean, we can think about this coming from something like this. You see, and this is just the top of a bar. Now, I'm not going to go through this with all of them, but I think it's important to know that frequency polygons come from histograms, and this is the histogram from which it comes. Okay, so that's the idea. Now, so we have a number of states falling within each of these intervals that are down here. And these are those class intervals that we talked about before. Well, let's answer a question here and go through a little interpretation. We can easily see that the more states fell into this interval than any of the other intervals, and the least number of states fell into the interval of $34,000 to $38,000 for per capita income. But let's answer this question. It says, what percent of the states have a per capita income between $22,000 and $26,000? You see, again, this is the interval idea associated with the notion of frequency polygon or histogram. All right, now we're looking for a percent, so we might use this percent statement that we started with before. What percent of the base is the amount? What percent of all of what we're surveying, all of what we have in our study, is the amount that we're talking about that falls within this interval? So what percent? That would be n percent. Of means times. Base, the basis of this, the states that were surveyed, you see, are all 50 states, so there are 50 items in the survey. And how many of them fell within, is means equals, and how many of them fall within this interval of $22,000 to $26,000? Let's look back over here. So the interval from 22 to 26, that's this interval. So at the very top and middle of that interval, we have the number 20. So we use 20 then for the amount over here, and away we go with our division. So this is 50n on the left. We're going to divide by 50 to eliminate that 50, and on the right we need to divide by 50 as well. And when we divide, we find this to be 0.4, and as a percent, it is 40%. So 40% of the states have a per capita income between $22,000 and $26,000.